Hey guys, welcome to chapter 18.1, part 3. We're talking about the difference between positive and negative regulation. So the lac operon is under two or dual control. It is under negative regulation. In negative regulation, which is what we've been talking about with the trip operon and the lac operon, that is when a repressor or a regulatory molecule binds to the DNA and blocks transcription. So negative meaning that it's going to stop or lessen or decrease the amount of transcription. So that is a negative gene regulation, and that should make sense. So the trip operon has a repressor protein and a co-repressor that turns on the repressor, and the lac operon has a repressor molecule and an inducer which turns off the repressor. Those are both forms of negative gene regulation. You might find a different definition from other sources, but this is how it is being taught now, that both of these are negative gene regulation. Positive gene regulation occurs when a regulatory protein, so like that repressor, but now not a repressor, is going to attach onto the DNA, and it's going to stimulate or cause more transcription. So that should make sense, positive gene regulation. So when lactose and glucose are both present in the cell is going to break down glucose first. This is because it's a smaller molecule and it is easier to break down. It takes less energy to get energy, so it's going to break down the glucose first. However, when there's not a lot of glucose around, or if there's not any glucose around, the amount of cyclic AMP is going to build up. So remember, that's an ATP but minus two phosphate groups. So that's going to build up if there's no glucose because cell respiration can't happen. And so the ATP is going to become less abundant, and the CAM, the CAMP is going to become more abundant. And so when CAMP is more abundant, it's going to interact with the CRP molecule. It's going to, or the CAMP receptor molecule. And that CAMP receptor molecule is going to then attach onto the DNA, the gene or the operon, and it's going to stimulate transcription. It's going to, basically what it does is it allows or creates an affinity for the RNA polymerase to transcribe more. I said that wrong. So the RNA polymerase is going to have a greater affinity to attach onto the DNA. So therefore, a greater rate of transcription will happen. So this is going to help the cell to break down lactose because there isn't any glucose, so making itself available to break down lactose since there is no glucose. If the amount of glucose in the cell increases, then the amount of CAMP is going to decrease because cell respiration is going to start up again, and it's going to take all that cyclic AMP and it's going to turn it into ATP. So then there won't be enough CAMP to attach onto the CRP, and then the lac operon will start to function at a decreased rate. So the RNA polymerase is going to have a lower affinity for the operon. So the lac operon is under dual control. It is under negative control by the lac repressor, and it is under positive control by the CRP molecule. So the repressor with the allolactose is going to turn on the gene or off the gene if there's, depending whether or not the allolactose is present. So this is going to either turn on or off the gene. However, CRP is only going to control the rate of transcription. So it's a little bit different, but this is the difference between positive and negative gene regulation. I hope that helps, and let me know if you have questions.